Okay, this is the P2 paper from June 2024. It's question number 5, and this is an algebraic methods question, in particular mathematical proof. We're told that if this is true for two positive numbers, can we show that y is greater than x? And then the second part is using a counterexample. Let's focus on the first part though to start off with. It says, given that x and y are both positive numbers and x minus y cubed is greater than x cubed minus y cubed, can we show the second part? Yeah, absolutely we can, by focusing on x minus y cubed. Now, if you wanted to, you could use the binomial expansion to do this. You've got Pascal's triangle. You could do it quite quickly. I'm not going to. I'm just going to simply multiply them out. It's only to the cube. So what I'm going to do is say this is x minus y times x minus y squared. So this is x minus y multiplied by, I know what x minus y squared, it's x squared minus 2xy plus y squared. So multiplying that out is going to give me x cubed minus 2x squared y plus xy squared, and then multiplying by the minus y minus x squared y plus 2xy squared minus y cubed. So that all tidies up to x cubed. You've got minus 3x squared y's. You've got plus 3xy squareds, and you've got minus y cubed there. So now what I'm going to do is I'm going to start off with this part here. If x minus y all cubed is greater than x cubed minus y cubed. Let's try it. X cubed minus 3x squared y plus 3xy squared minus y cubed. We've been told that that's greater than x cubed minus y cubed. Well, we can see that they're going to cancel and they're going to cancel straight away. So let's actually just do that, and we'll end up with minus 3x squared y plus 3xy squared is greater than 0. We can factorize that. If we take 3xy out, I get left with, just be careful here, y minus x inside the brackets is greater than 0. Now, x and y are both positive. Because x and y are both positive, 3xy must be positive. 3xy must be greater than 0. So that just leaves me that y minus x has to be greater than 0, which then leads me that y has to be greater than x. So brilliant, that's the first part proved. If that's true, then y must be greater than x. Part B then says, using a counterexample, can we show that that doesn't work for all real numbers? So let's look up here at the proviso that they put in. They said this works for positive numbers, so I'm guessing it's not going to work for a positive and a negative value. And obviously I've already done it, so I know that it doesn't. Let's try it. So let's say, is this true for x positive and y negative? And I can tell you already it isn't, but let's just show it isn't. So said counterexample, let's pick a value, x equals 3 and y equals minus 1. If x equals 3 and y equals minus 1, do we get this first part up here? Do we get that holding out to be true? Or rather, do we get that holding out to be true? That's what I'm really doing. X minus y cubed. So x minus y cubed should be greater than x cubed minus y cubed. Let's try it for 3 and minus 1. We'll have 3 minus minus 1 cubed is greater than 3 cubed minus 1 cubed. And what we get there is 64 is greater than 28. So that's okay, that works. But y greater than x would give me that minus 1 is greater than 3, not true. Therefore, what was the language they used? Not true for all real numbers. Therefore, not true for all real numbers. Okay, yeah, so proof ones, we don't particularly like them, do we? But just try and do as many of them as you possibly can, and the more you do, the more sense they will make. Okay, hopefully that will make sense to you all anyway.